Hi, I'm Tony Northrup for TrainSignal, and in this video lesson, we're going to learn how to monitor system performance on Windows 8. This lesson maps to Objective 6.3 of the Microsoft 70-687 certification exam. This lesson doesn't cover all the sub-objectives. It doesn't cover the event viewer-related sub-objectives. In this lesson, we're going to focus on the system performance-related sub-objectives. The first is to configure Task Manager. In Task Manager, you probably used it in earlier versions of Windows, but it's the most useful tool for getting a quick snapshot of your computer's performance, as well as ending tasks that are a problem. And in Windows 8, they've improved Task Manager so much that alone is reason to upgrade to Windows 8, I think. The next sub-objective is to monitor system resources. And you can do that with Task Manager, but we're going to dig even deeper and we're going to get into performance monitor and data collector sets and just really get our hands dirty inside the system. And the next sub-objective is to optimize networking performance. And there's not really anything special we need to do here. We've configured managing network performance before, and I'll show you how to examine the different network performance counters so you can get a good idea of what's going on. But optimize, the word optimize is a little confusing because it's pretty much optimized by default, and besides configuring it, there's really not much more to cover, so we won't spend a lot of time on that particular sub-objective. And likewise with optimize the desktop environment. There's not a slider you can move back and forth that improves the performance, but we will study performance monitoring in general. So if there were something you could do, we'll cover it. And finally, we'll wrap up the lesson by configuring indexing options. Indexing options configure the search capabilities built into Windows 8. So by default, it doesn't, for example, index all the files on your computer. We'll show you how to index an extra folder, as well as to configure other settings related to searching. Now let's cover how to use Task Manager. Here we are on our Windows 8 Enterprise computer, though all versions of Windows 8 have Task Manager in it. There are a bunch of different ways to open Task Manager, and it's such a powerful tool that it's important to know them. One of the easiest is to open up the WinX menu, which you can do by holding down the Windows key and pressing X, and then selecting Task Manager. You can also just right-click in the lower left corner and then click Task Manager. Another is to do the old three-finger salute, Control-Alt-Delete. And then in the screen that pops up, click Task Manager. There's our Task Manager. You can also press Control-Alt-Escape to open Task Manager directly. So this is Task Manager, and now let me open up a couple of apps here so we have some things to browse. Now you can see by default, Task Manager simply shows you whichever apps you have running, and this will include both Windows apps and Metro apps. Let me open up a Metro app while I'm at it. We will check out our Finance app, make sure that gets running before I switch away. All right, so let's jump back to the desktop so that we can see Task Manager again. So here you see a mix of both desktop apps and Metro apps. It doesn't really show you much, but on this first screen you can select something and then end it here, which is exactly like closing the window. You saw that Metro app disappear. That's how Metro works. If these, well, they call them Windows Store apps or Microsoft Store apps. But this new generation of app will automatically suspend itself in the background when you're not interacting with it, unless it's specifically configured to continue running. So something like Pandora, which plays music in the background, will keep running. Something like Finance, which is only useful when you're interacting with it, it'll disappear after a second. So that's why we saw that app disappear. But we still have a couple of desktop apps running here. Now you'll notice I have Explorer running here and Task Manager running, and neither one of them show up in Task Manager. They're both considered Windows components, and so they don't appear here, but we can see those processes elsewhere. So by default, you get this really simple interface, which is much simpler than it was in previous versions of Windows. But we can click more details here and see even more than was in previous versions of Windows. So I'll just maximize this window. Now you get just about everything you need done on the Processes tab. Here, under the list of apps, you can see not only the two apps that we were running, but also Task Manager and Windows Explorer. So you can see on the main page, they were hidden by default. You also see a whole bunch of background processes, and there's always a lot of background processes running, and it's generally fine. Now, I don't agree with people who try to close down everything that's unnecessary. People want their computers to run as fast as possible. That's something we all want. But this kind of obsessively chasing down these background processes really generally isn't worth your time. So, for example, I'm not using Adobe Flash right now, but you can see the Adobe Flash Player utility is running, probably because it's a component in Chrome or Internet Explorer, and it would allow Flash to run. Actually, maybe that page doesn't have a Flash player, but it's running and it's consuming 1.9 megabytes of memory out of however many gigs a computer has. It's a very small percentage of the overall memory, and it's consuming 0% of the processor time, as well as no network and no disk utilization. So that's true for all of these background processes. They're consuming hardly any memory, no disk, no network, and no CPU. Oh, we saw a little blip here. Runtime Broker did something, and then it stopped. Anyway, these background processes generally aren't slowing down your computer, so I wouldn't worry about them unless you see one of them using a bunch of some of your system resources. And that's the power of Task Manager, is you can identify exactly what's going on your computer. So how many times has your computer been slow and you have no idea why? I yell at my computer. I will be like, computer, what is it you're working on right now? You are supposed to do what I tell you, and it seems like you're doing something I don't want you to do, and you don't have time for whatever app I just asked you to run. So when that happens, I open up Task Manager and I figure out what the heck it's doing. And if it's not something I want it to do, I'll stop it. And stopping it's as easy as selecting it and then clicking End Task. That's not a good example. You don't want to stop system. The system process here has a ton of everything in it. All these background services run inside system, and you can't kill it. You'll see the End Task is grayed out there, but the anti-malware services executable isn't something you always need. Of course, anti-malware, Windows Defender, tries to stop bad stuff from running on your computer. We'll just close it down here. You can see it's consuming 21.8 megabytes of RAM. Yes, shut it down. And that little bit was enough to make my total memory utilization go from 40% to 38%. It's never going to improve the performance of any of my apps in any kind of notable way, which is why I encourage you not to go chasing down background processes and Windows processes unless you see them consuming a lot of processor utilization. So how do you find the ones that are using all your processor time? Well, of course, you can just scroll through and look for the big numbers, but a quicker way is simply to click these column headings. By clicking CPU here, it went from sorting it by names in groups to showing me the apps that are using the most processor time right at the top. And you can see that's going to be either Internet Explorer or Task Manager for me right now. Internet Explorer opened up to a rather active page, Microsoft's default page, which I think is MSN, which is why it's consuming so much processor time. Even though I'm not even using it, right? Like, you'd think it could be like, we're not going to show any animations until the guy at least opens up the window. But unfortunately, that's not the way the desktop version of Internet Explorer works. One nice feature of Task Manager that earlier versions didn't have is it will group process trees together. So in Internet Explorer, I'll jump over to Internet Explorer and open up another tab. Let's just go to Train Signal. And how about we check out my photography page? All right, so now we have 3 tabs open up, and when you jump back to Task Manager, you'll see those grouped under the single process. I'll sort that by name so it doesn't jump around so much. And that's really nice because in earlier versions of Windows, Windows 7, Windows Vista, when you looked at the Processes tab of Task Manager, it simply displayed a list of every single process running, and they weren't really organized. But now, because Internet Explorer uses a separate process for every tab, it really generously groups them together according to the app. And that means there's far fewer entries here. And it's much easier to find the entry that you need. You can see Google Chrome uses a separate process for each tab too, though it only has one tab open at the time. Now you can't identify which one of these tabs is using all your processor time, but nonetheless it's easier to track down. Now by right-clicking any process, it gives you a couple of options here. You can force the window to maximize or minimize if the app happens to support that. You can also switch to it or bring it to the front. So if there's an app that you can't find, this happens sometimes. Sometimes a window will move off screen and you want to get to it to do something, but you can't physically reach it with your mouse. You can right-click it and click maximize, and that'll bring it right to the front here. The default entries for CPU, memory, disk, and network are the most useful. You can also right-click a column heading to show other entries. For example, the process ID can be useful to know if you're going to try to monitor something from a command prompt. So here we can see that Internet Explorer is using processor ID 52 and Google Chrome is using process ID 2404. I'll open up a command prompt quickly with administrative privileges. And I think the command is called pskill. tskill? There we go. The tskill tool combined with a process ID will kill a process from a command prompt. And sometimes it's a little bit stronger than Task Manager is. So you can see I ran the command tskill 2404. That was the process ID for Google Chrome, and Google Chrome did indeed disappear. Killed it from a command prompt. Could have also done it by selecting it and then clicking End Task here. So these are some of the most important tasks of Task Manager. Figuring out which apps are using the most resources and sometimes killing the ones that are doing too much on a computer to free up resources for other apps. Now, older versions of Task Manager allowed you to monitor the processor and memory, but they didn't really allow you to monitor the disk or network in any kind of meaningful way. So this I find terribly useful, and this might be reason enough to upgrade to Windows 8. I just love the new Task Manager, and if you're an IT guy doing troubleshooting stuff, it really pays to know it inside and out. It gives you so much detailed information. I just love it. Let's move on to the next tab, the Performance tab. Whereas the Processes tab gives you detailed information about each individual process and what it's doing, Performance gives you a snapshot of the overall ongoings in your computer. I actually think Performance would be a better default tab than Processes, because when your computer is slow, the first thing you want to find out is it my processor is being used up, or am I running out of memory, or is the disk thrashing, or is some app using all my network bandwidth? And this Performance tab answers that question. You can see just from these little thumbnails here what's going on. Now memory's at 40%, and you can see this little line here is about 40% of the way up. If the computer were out of memory, that would be all the way up there. Same with the CPU. If it were spiking up here at the top, I would know something was taking up a ton of processor time. Real quickly, I just want to show you this link down here, Open Resource Monitor. Resource Monitor is this really useful app. Well, anyway, it was really useful in previous versions of Windows. I actually think Task Manager does everything that you need now. For example, if you open up Resource Monitor and then select the Disk tab, here we can see different apps and how much of the disk performance they're using. And it provides a little bit more information than Task Manager does, in that it's showing you both the bytes read and bytes written. Task Manager just shows you the total bytes over here. For the most part, I think just looking at the Processes tab in Task Manager is enough to identify the problematic app. But I do want you to be aware of Resource Monitor and the additional information that it can show. So I'm not going to go over Resource Monitor in a lot of detail, but on your own time, open it up and check it out. It's basically unchanged from earlier versions of Windows. So if you just have access to a Windows 7 computer, that's just fine. There's some additional information down here that's useful for kind of assessing the current computer, because as an IT guy, you're often asked to hop onto somebody else's computer, so you don't always know what the actual processor maximum speed is or how much memory it has in it. So I find Task Manager and the Performance tab specifically is a good way just to spec out the computer that I'm on. If it's running really slow, sometimes the reason is that the processor is just a slow processor, it's just a slow computer. So you can find out really quickly by going to Task Manager, and if it's, 10 megahertz computer, well, that's why it's slow. This is a 3.3 gigahertz computer, which is fast enough. You can also see that this particular PC has one socket and one core. Most computers nowadays will have 3 or 4. This happens to be a virtual computer, and I've only assigned it one logical processor. Selecting memory here gives you a little more insight into how the computer is using the total system memory. And unless it's at 95% or maybe 90% or above, you don't have to worry about the memory. The fact is that Windows scales memory usage pretty intelligently, so if apps aren't using all the memory, it's going to go ahead and kind of let them use all they want. Until it starts to run out of memory as a resource, will it begin to kind of throttle back and manage memory more carefully. So in general, if it's below 90%, everything's fine. And memory isn't one of those things that starts to slow down as it gets higher and higher. With processor, if it's at 90%, that means a lot of apps are waiting. With memory, if it's at 90%, that means everything's a-okay. Same thing with disk and Ethernet. These CPU, disk, and Ethernet all become bottlenecked as they become limited. Memory doesn't become a performance bottleneck until it's completely consumed. And here we can see that the memory in use is 855 megabytes out of a total of 2 gigs. So there's plenty of free and available memory for new apps that I were to launch. Just so you're familiar with the terms, you'll see paged pool and non-paged pool a lot. The computer has both physical RAM and virtual RAM, or virtual memory. And it has 2 gigabytes of virtual RAM and basically unlimited amounts of virtual memory, however much it can write to the disk. Virtual memory is a file on the disk, and if for some reason apps need more than the 2 gigs here, Windows is going to start to write memory for apps that aren't currently using that memory to the disk. If you go back to that app later, it'll read it back from the disk and kind of swap this memory in and out. So when you start to run out of memory, what happens is Windows swaps memory data from the physical RAM to the virtual RAM stored on the disk. Data that can be swapped between physical RAM and virtual memory on the disk is called paged memory, because the process of moving memory from physical RAM to the virtual memory on the disk is called paging. It takes a page of data, like a page from a book, tears it out, and then moves it over to the disk. Some memory, like the memory that the Windows kernel uses, can't be moved to the disk. It's stuck in physical memory, and that's called non-paged memory. So here on this computer, there are apps and Windows components that are using 191, 192 megabytes from the non-paged pool. These are stuck in physical memory no matter what. They will never ever be paged to the virtual memory file. There are apps and perhaps Windows components too that are using 132 megabytes of the paged pool. This can be freely moved between the physical disk and the physical RAM. Paged pool memory is a lot less expensive than non-paged pool memory. Now, I'm not talking dollars here, I'm talking about memory as a resource, because you can't really run out of your paged pool because it'll just move some more stuff to the disk. You can run out of your non-paged pool, and if this number were to get much higher than 200 or 250, you might begin to wonder what's going on. Most apps only use paged pool memory, so you shouldn't see the non-paged pool memory go up very high. This should be reserved for just system components. Let's take a look at the disk settings here. You can see the disk isn't doing a whole lot right now. It does happen to tell you the capacity of the disk and whether the disk that you're looking at here is a system disk and whether it has a page file on it. If we look at a different computer that has multiple disks, we'll see different entries for each of those disks. And here in the Ethernet tab, it shows us what communications are currently happening. Oh, something just happened. I'll switch over to a web browser here and we'll just do some browsing and see if we can generate some bandwidth. All right, just flip through these pictures real quick and then jump back here. So while it was downloading those images, the network activity jumped way up. Before we move on to the next tab, I'm going to jump over to a different Windows 8 PC that has multiple cores and multiple disks, just so you can see what the task manager looks like. So this is another Windows 8 computer, a bit beefier one. And I'll open up Task Manager here and jump over to the Performance tab. So here we can see there are separate tabs for each of the 3 different disks that it has. This computer has 3 different Ethernet adapters. You can see one of them's in use and the other 2 are not, so all the traffic is happening on this one. And looking at the processor, you can see that there are 12 different cores and logical processors, but it's still just kind of summarizing the overall utilization, and that really is what you want to see. Now, you can right-click it and click Change Graph to, and then select Logical Processors, and this will show you the performance of each individual processor core. This is useful because most new apps will try to spread the processing that they need to do across all the different cores. However, some apps are still what they call single-threaded, and a single-threaded app can only run on 1 core at a time. So if you have an app that's running slow, it might be limited by the processor. In this case, because there are 12 processor cores on this computer, if one processor is running flat out at 100%, the overall utilization would still only be about 8%, because each of the 12 processor cores contributes about 8% of the overall potential utilization. So what you'll see in that case is if a single-threaded app is limited by the processor performance, you will see 11 board processors doing nothing and then 1 processor pegged at 100%. That one app isn't going to run any faster because it only runs on 1 processor. However, you could run other apps and they would just use any of the remaining 11 processor cores and they would perform just as if that one app utilizing the 100% of the 1 processor core wasn't running at all. So let's look at the App History tab here. The App History tab shows you which apps have recently been run, as well as how much time they took and how much network utilization occurred. Now, when a problem is actively going on, if you're like, my computer's slow, what's going on? You look at the Performance tab and then the Processes tab. If a user comes to you and they say, my computer is slow often, but it's not slow right now. This happens. Like anytime you try to demonstrate a problem, whether it's your car or your computer, when you go to show it to somebody, it doesn't do it, right? So sometimes users will call you and they'll be like, my computer's slow all the time, and you'll get there and they'll be like, well, it's not doing it now. But it was earlier. Here's what you can do. Jump to the App History tab of Task Manager and then check out what apps have been doing what. You'll be able to see exactly what apps they've been running and how much processor time they're using. So here we could blame any potential processor utilization problems on the mail, calendar, people, and messaging apps, which all run under a single process. If you're monitoring the network and you see some user is transmitting an awful lot of network data, this happens. People stream music, they download stuff at work. You can open up Task Manager and select the App History tab, and maybe you'll see BitTorrent, or maybe it'll just be Internet Explorer or a different browser, but it will allow you to figure out exactly what they're doing. Maybe it'll be this video app here. If you get a cellular data bill, that's really expensive. Again, go back to the App History tab and sort it by metered network here, and this will tell you which apps are using your metered network rather than your Wi-Fi network. And they've included the tile updates column here. These are the live tiles on the start screen here. I have them turned off, but generally these will update with, for example, the latest travel information or the latest sports headlines. And the tile updates have to download little bits of data and sometimes pictures. So switching back to the desktop, all the data transferred for these will appear in this column here. It's always going to be a small number. It's never a substantial amount. Microsoft, I think they just include this because they anticipated everybody being upset over how much bandwidth these live tile technologies would consume, and they wanted to be able to tell people, look, it's not a big deal. If you think it is, just go to your app history and you can see how much is consumed. It really is pretty small amounts, and generally it's not over metered networks. You can see here the tile updates didn't occur over a metered connection. Let's take a look at the Startup tab. This is a great addition because in the past, apps that start automatically have been a real pain. After you use your computer for a couple of years, you can have dozens of apps just starting automatically, various utilities and, Adobe Updater and then iTunes Updater, and then iTunes has different apps to monitor for when you plug your phone into your computer, and Anyway, you'll have dozens of different things, and they all slow down the startup process. So one of the goals with Windows 8 from Microsoft is to give users control over which apps start automatically. This helps not only speed up restart times, but it also helps minimize the overhead of running all of these apps, minimizes the amount of processor and memory that they use. So you can jump over to the Startup tab here and turn off any app that starts automatically just by selecting it and clicking Disable. I actually want this. It helps me use the virtual machine that is this computer. The Users tab shows you the users who are actively logged in and any tasks that they happen to be running. Now, when we look at the Processes tab here, we see a lot of tasks that aren't under Users here. You can see I'm the only user logged in, and though it's got about 10 different tasks here, there's far more listed on the Processes tab. The difference is that the Processes tab shows all processes for all users and all system processes. So we can see any malware service executable is running here, but it's running under Windows rather than under my user account, which is why we don't see it when we look here. Something useful here, if there's another computer account logged onto a computer and you don't want it, you can open up Task Manager and then click Disconnect. That requires administrative privileges, of course. Basically, it logs the user off forcefully. And the Details tab, and this will look familiar to anybody who used earlier versions of Windows. It basically looks just like the Processes tab in earlier versions of Windows. So if you're familiar with this format, if there's some piece of data that you just know how to find really quickly, this is a good way to do it. You can see we can sort by processor and memory. But nowadays, once you get used to the Processes tab, I just find it so much more useful than this Details tab. I really think they keep this around just for historical purposes. As with earlier versions of Task Manager, there's a lot of different columns you can select on the Details tab. Just right-click a column heading and then click Select Columns. And this will show all these different pieces of data about every process running on your computer. So for example, we talked earlier about the importance of paged pool versus non-paged pool memory. If you want to see exactly how much of each individual apps are using, you can select these two columns. And now I can quickly sort it by the non-paged pool and see which apps are using the most non-paged memory. So, as I was describing earlier, if you're on the Performance tab and you're looking at the memory and for some reason the non-paged pool is 2 gigabytes or some large number, jump over to the Details tab, add the NP pool column, and then sort it. And you'll probably see some app that's using a bunch of it. Now onto the Services tab. The Services tab lists every service that's running on your computer. I find it most useful to sort it by the status. These services, for the most part, are things you shouldn't mess with. Almost all of these are going to be Windows system components, though third-party apps can and will install services. Now, a service is just like an app, except it runs in the background. Usually services run automatically without you initiating their start. Like, you don't have to go to the Start menu and click a button to start your print spooler. The print spooler, which is responsible for receiving print jobs and forwarding them onto a physical printer, runs automatically every time you start Windows and just waits for you to send a print job to it. It's important and useful, and you want it to be running and you don't want to mess with it. But if you ever want to investigate which services are running, you can visit the Services tab here. You can also right-click it and stop or restart a service. You can also do this from the Services console in the Computer Management tool, but the Services tab on Task Manager just happens to be convenient. If you want to open up that Services tool, just right-click something and then click Open Services here. And this is the full Services console. So this is an example of a third-party service, the VirtualBox Guest Edition service. This is not included with Windows. It is installed as part of a third-party app to help me manage this virtual machine, and you'll find lots of third-party apps install services. For example, the popular iTunes installs a service just to communicate with the iPhone or your iPad or whatever Apple products you might have. And these services are generally useful. Sometimes you'll install an app that installs services you don't really want. Like, I really don't care about the Adobe Reader updater. It's a service that runs automatically and it's just checking for updates and generally annoying me. It's not consuming a lot of processor time, but if I don't like it, I could right-click it and then click stop, or I could view the details of it to get more information about it. For example, to see just how much memory and processor it's using, to see whether it's something I need to worry about. This would allow me to assess whether or not it's impacting the overall system performance. You'll see this search online option here, and that's literally what it does, is just searches for the name of it. And you'd think, since they built that search online link right into Task Manager, that it would go to some Microsoft service where they like record what different services are. No, it just throws it into Bing. You can see it's just the process name, both the computer-friendly name and the user-friendly name here. And then you just get whatever Bing gives back to you. So do that at your own risk. I guess that's a little easier than trying to copy and paste the name. Up next, another real-world scenario, and the bandwidth hog. This is easy. Your internet is just really slow, and you're thinking maybe some app is using up all your bandwidth. So let's fire up Task Manager and see what's doing it. Here we are on our Windows 8 computer, and I'll just use the WinX menu to open up Task Manager. And we'll start with the Performance tab here to get a snapshot of the overall network utilization. And you can see this is using up pretty close to 32 megabits of bandwidth here. Right now it's over 20 megabits per second of bandwidth. That's a lot. Let's see if we can find out which app is doing this to us. Jump over to the Processes tab and then sort it by network utilization. Look at that. Google Chrome is using 26 megabits of bandwidth. And you can see there's a page open here that seems to be using up all that bandwidth. Well, know how to fix it, right? You could go to the app and close it, but the easiest way is just to click End Task here. And it's gone. Go back to the Performance tab, and sure enough, our bandwidth utilization dropped to 0. So this problem seems to be solved. As a side effect, note that the CPU and memory utilizations went through a huge drop at the same time. So Google Chrome was really using a lot of processor, memory, and bandwidth, and we were able to identify it really quickly and stop it. Now, sometimes you'll get Task Manager open and nothing will be happening. Maybe the app managed to hide itself in time. There's always the app history here. Just jump to the app history tab and sort it by network. But the problem with the app history tab is it doesn't work for desktop apps. It just works for the new Windows Store apps, the Metro app. So we don't actually see Chrome in here because that runs as a desktop app. Now let's check out what is literally my favorite tool in Windows, and that is Performance Monitor. Oh, I've loved Performance Monitor from the first day I saw it back in Windows NT. It's the coolest thing. Let's jump right into it. So here we are in Windows 8, and I think the easiest way to get Performance Monitor up and running is to just use the WinX menu and start the Computer Management Console. Now, under System Tools and then Performance, we will see Monitoring Tools, and finally we can select Performance Monitor here. And this has not changed a bit, really, since Windows NT. Back in the 90s, they haven't changed it, but then again, they haven't really needed to. It still does a great job. So this is a chart, and there's nothing in the chart. It used to be that they, by default, added the processor utilization and a couple of other counters, but there's nothing like that added by default anymore. So you just click this green plus button up here to add a counter. Now, there are tons of counters. There are, I don't know, more than 1,000 counters, certainly. And they cover every aspect of system performance, from network utilization to processor utilization. Far, far, far more than you can get in Task Manager. So probably the most popular one is processor and then total. Now, this particular computer has a lot of processor cores, 12. So when I select processor here, you'll see that it allows me to select any of the 12 different cores, or I could add all 12 cores, or I could use the underscore total object here to view the sum total of all the processors. This can actually expand to show you the different types of processor counters. So if I simply select processor here and click add, you'll see that it will add all of the counters located within the processor group here. So for the sake of this example, we'll just add all the processor counters and then click OK. What we'll see now is Performance Monitor begins instantly monitoring all the different counters in real time. Now I'll select the first one here, which is the most useful one, which is the % of the processor time currently being utilized. You can see the counter name here. And as I said, it shows the instance for total. That means it's the sum total of what all the different processors are doing. Now, because we have so many different lines on this chart, it can be a little hard to see the current processor time as part of the chart. So what you can do is press Ctrl-H on the keyboard to highlight the particular counter that you're currently monitoring. So this is showing us the current processor time. Now, you can get that from Task Manager much more easily. And if you just want to monitor processor time, you should indeed go to Task Manager. But with Performance Monitor, you get all this other useful information. For example, the interrupt time, which is the amount of the processor that's being consumed by hardware components that bother it to do something hardware related, like send a network packet. You can also distinguish between user time, which is the amount of time different applications consume, and privilege time, which is generally reserved for core system components like the kernel. Now, besides looking at the chart itself, I find it really useful to look at these little counters here. Last is the last value, most recent value, provided by the counter. So it's constantly updated with whatever the most recent information is. Average is the average value across the entire course of the visible chart. Minimum is the smallest value. So in this case, it would be the least amount of privilege time that had been consumed while the chart was open. And the maximum number here shows the highest value that it has been since the chart has been visible. So let's take a look at some of the other counters. Of course, processor shows different aspects of your processor utilization, and I do think that's maybe the most important one. Another important one is physical disk. This shows you just in minute detail different aspects of your current read and write times. The queue is how many bits of data, how many bytes of data are waiting to be written or read from the disk. We can see the number of actual read requests versus the number of bytes that are read. And if you understand hardware at a detailed level, this is immensely useful. The power meter counters here show you information about the battery and how it's being utilized. The print queue, of course, shows you information about the printers. Process is a little bit different than processor. Process is for analyzing what a specific app is doing. So when we select any of the process counters here, we get a list of different objects that can be selected, and these are the different processes that are running on the computer. So we can see here that Internet Explorer is running with several different tabs, and I could monitor the ongoings for any of those, as well as any other process running on the computer. RAS, Remote Access Service, is for VPN and dial-up connectivity. ReadyBoost is this now deprecated service that could speed up your computer a little bit if you put a USB flash drive in there. Most of these aren't things you use very often. Search Indexer allows you to monitor how much processor utilization the search service is using as it indexes the files on your computer. Server is for file and printer sharing. SMB is a really old name for just file and printer sharing. It's server message blocks, also called NetBEUI. So this allows you to monitor the current number of sessions, both as a client and a server. System has some detailed information about the system itself that aren't covered under anything else. For example, if you want to monitor the ongoing number of processes, you could use that. The processor queue length gives you information about the number of apps that are currently waiting for the processor to do something. System uptime is a cool one. You can see how long the computer has been running. TCP v4 and v6 are components of the network stack. TCP is used by applications that need reliable communications, like a web browser, for example. TCP v4 is far more common. TCP/v6 is the new generation of networking technologies, but it's not really used by very many apps right now. Teredo is IPv6 to IPv4 technologies. Basically, they let you use IPv6 apps across IPv4 networks. Terminal services are remote desktop, just a fancy name for remote desktop. Thread provides you information about individual threads. It's a little confusing and it's not something you're going to see in detail in the test, but an app can have one or more processes. Process can have one or more threads. For example, Internet Explorer opens a new process for every tab. Each tab in turn could open up multiple threads to do more than one thing at once. So for example, if you go to a YouTube page, Internet Explorer would open a process for that tab. The YouTube page itself would use multiple threads. One thread would probably run Adobe Flash to show you the video, while another thread performs some work in JavaScript, for example, to make the menu systems work properly. Just like we had counters for TCP/v4 and TCP/v6, we have counters for UDP/v4 and UDP/v6. TCP, as I mentioned, is reliable communications. UDP is unreliable communications, and I don't think the test is going to test you on these things, but browsing the web uses TCP. Looking up DNS names uses UDP. So different apps use one of those two different network protocols. USB, of course, allows you to monitor the ongoings of different USB hardware that you have connected. For example, the amount of bandwidth that they're currently using. That's USB bandwidth, not network bandwidth. I'll jump back up to the top of this list so we can cover some of these at the beginning of the alphabet. All these different .NET counters. .NET Framework is an application development framework. So .NET Framework apps all run within the .NET CLR, the Common Language Runtime. And if you're an app developer, you might want to monitor what exactly your app is doing. If you are in charge of administering a .NET Framework app, you might find those useful too. BitLocker we've covered in different lessons, but it provides disk encryption. Branch cache we haven't covered because it's more of a server side topic, but it can speed the performance of file access across an intranet when you have to access something in a remote office. Browser is not your web browser. This is the browsing capability to find resources on the local network, and it's kind of outdated. It's probably not something you'll ever need to monitor because it was more useful in earlier versions of Windows. There's still a fax service if anybody goes back into the 70s and needs to fax a document. The HTTP service is a web server service. You might also see IIS installed, though this computer doesn't have it installed. ICMP is another network protocol that you can monitor. ICMP is used for ping and for different types of messaging between computers and routers and such, but it's not the type of thing you usually monitor. IPsec we've covered in a different lesson, but that is secure IP communications, basically authenticated and encrypted communications. And here you can separately monitor standard IPv4 and IPv6 apps. Memory, of course, this is a really useful one. This allows you to monitor how much memory is currently being used, including information like the paged and non-paged pool. So you can get a lot of this information in Task Manager, but you can get even more detail here. I skipped over logical disk, which is basically the same information that you can get with physical disk, except it will show you your C drive instead of your disk 0 drive. Basically, it's just two different ways to look at the information, whether it's organized by a physical disk, which might have multiple logical volumes on it. Logical volumes can also span multiple physical disks, so two different ways to look at the same information. The network adapter and network interface performance counters here are useful too for monitoring your network utilization. Offline files, if you take advantage of that feature, we covered it in another lesson, and you want to see exactly how much it's transmitting and receiving, you can add that to Performance Monitor and see it in real time. I talked about paged and non-paged pools. Well, if you want to monitor exactly how much of your paging file is being used, you can do that right here with the paging file counter. So that brings us back around and completes our tour of Performance Monitor. I highly recommend you just open it up on your own computer, no matter which version of Windows that you're running, and just leave it running while you do stuff. Add some different counters just for fun and investigate them. I'll show you really quickly. You can get a description for any of these just by clicking the Show Description button here, and it will tell you a little bit more about that individual counter. And it's a great way to learn how your computer runs. So I kind of gave you the highlights, but there are thousands of different counters in here that I can't possibly cover them all. And they won't expect you to know all of them for the exam, but you should be familiar in general with how they work. And like I said, just as you're going about your daily business, open up Performance Monitor, add a bunch of counters to it, and watch how they change as you do different things on your computer. Just get some real hands-on, real-world experience with it, because it's pretty cool. Now for another real-world scenario. Mary called you again. I know, right? And she's complaining that her computer seems really slow, and it seems like it's busy doing something that she didn't tell it to do. And every time you go by to see what's going on, she says it doesn't do it. She says it only does it when you're not around. So she calls you and then it doesn't happen. Well, we can use data collector sets to monitor a computer when we're not there. It works just like Performance Monitor, except it runs in the background and collects the data, and then we get to analyze that log later. So she can just make note that, oh, I don't know, it happened half an hour ago, it happened at 2 o'clock, and then we can look at the log and see exactly what was going on at that time. So let's set that up on her computer. So here we are on Mary's computer, and I'm going to open up the Computer Management Console to create a data collector set. Now, data collector sets are managed right next to the monitoring tools that we just used. Here they are. And there are a couple of built-in data collector sets, but I think it's best here if we just create our own custom user-defined data collector set. So I'll right-click user-defined, click New, and then data collector set. We'll call this Mary's Performance, and we'll just create this one manually. They do have a couple of templates you can use, but we'll do this ourselves. We're going to monitor the performance counter logs, and now we'll specify the performance counters that we're going to monitor. So we get all the same counters that we can monitor in real time using the Performance Monitor tool, except these get logged, so we can easily monitor them later. So I'll add all of the processor counters. I also want to do process, because this will let me see individual processes that are running. I'm going to select all instances here. And while we're at it, let's add memory as well. And just to be sure we're covered, we'll add the network adapter. That way we can tell if she's going through a lot of processor utilization. So we have a lot of different counters here, and that's going to create quite a big log file, but it'll allow us to be sure that something's going to be captured. By default, it will monitor every 15 seconds. So it shouldn't be generating so much data that it will overload the computer. If we had it monitoring every second, well, just creating the data collector set would start to consume a lot of memory and processor time. So I'll click Next, and this allows us to choose the folder where the data is going to be saved, and we can leave it in that default directory. And here you can specify the user that it runs as, but the default is just fine. So we'll go ahead and save and close it, though you could choose to start it right from this dialog. So our data collector set is created here, and I'll just click this green button up here to start the data collector set. So now you can see it is actively monitoring her computer, and we can close this console and let Mary go about her business. So let's hand the computer back to Mary, and we'll check back in a couple of minutes. So a few minutes pass, and Mary says she's on her way to lunch, hard worker that she is. So let's hop on her computer and see if we can figure out what was going on. I'll open up the Computer Management Console again, and let's find our data collector set. Just going to right click it and stop logging. Now let's make a note of where it is. You can see it's under perf logs. And we'll go into monitoring tools and performance monitor, and let's open up the log data. I'm clicking the second button here, view log data. And normally it's set to current activity, which lets you monitor in real time. Let's select the log file instead. And there is her log file. Now you can see here from the time range that it will show the entire time span, which seems to be about 10 minutes or so that it was actually running. Of course, it can go on for days if you want it to. And now that I've changed it so we're monitoring the log file, you'll notice there's no chart that appears. You still have to click the green button up here to add the individual counters that you want to monitor. So just to keep it simple, let's just start by adding in the total processor time. So now we can see, looking at it, yes, the processor was pretty busy from about a few minutes after we left to right before we hopped back on the computer. So Mary is doing something with her computer that keeps it pretty busy. And you can see it makes it pretty easy to zoom right in. I just drag to select, and then I'll right click and click zoom to here. And that limits the time span just to the part where it's busy. This slider here controls the amount of time that you monitor it as well, just another way of doing the exact same thing. So you can adjust this down to just see the times when the computer was really being a problem. Great, so now we have the computer's busiest time, and the processor time overall is indicating that it was indeed busy. Let's dig into the processes a little bit and see if we can figure out which process was using the most processor time. I'm just adding in all instances under the process object. And indeed, that's a bit too much. Okay, so let's remove those again. I'm going to just select everything and then remove the counters. Now, let's do this a little bit differently. I accidentally added all these different processor counters. And what we really want is percentage processor time for all instances. So let's add that and then click OK. All right, that's better. Now we have a more manageable number of counters. Now our challenge is to figure out which of these is consuming all the processor time. Now, as I select this one, I'm going to press Control H on the keyboard to highlight it. And you can see this particular process, Search Indexer, didn't use a lot of processor time. It averaged 0.05% of the processor, so it's not the problem. I'm just going to quickly scroll through here so we can see what is using the most processor time. The system averaged 14%, so that's a substantial amount, but it's not the total amount that it was using. Okay, just scrolling through, I see that this chart, look, this is 0, and then this app seems to be using up just about all the processor time. Let's look at the process name there. Angry Bird Space. Mary, you called me to complain that your computer was too slow, and it's because you're playing Angry Birds. Well, that's not a good use of company resources, Mary, and I feel like I should report you. I'm not going to report her because, frankly, I just wanted to play Angry Birds for a while, and it was a good way to demonstrate something that used up a bunch of processor time. But you can see, without even being there, we were able to monitor really closely what was going on with the computer and then identify the process that was consuming all the processor time. Another way to do the same thing, since this is a Windows Store app, would be to go into the Task Manager and look at the app history here. And then we could sort it by CPU time, and you'll see Angry Bird Space jumps right to the top with 46 minutes of CPU time. Okay, maybe I got a little carried away as I was creating the demo. Angry Birds turns out is a really good game. You can see Mary's been doing some web browsing too. Internet Explorer is using up a lot of the network capacity. All right, so we have solved Mary's performance problem by using data collector sets, and she's a little bit busted. Turns out we can tell her computer's slow because she's not supposed to play video games on it. All right, one last real-world scenario in this lesson. And this one we need to add a new folder to the search indexer. You have some encrypted files on your computer and they're not stored in the documents folder. They're stored under C:"my files. The search indexer by default will scan all the files that you have in your user profile. But if you store files outside of your user profile and you don't add it to one of your libraries, well, it's not going to get indexed. So we have some log files, they're text files, that we want to index it. Also, another challenge is they're encrypted, and the search indexer by default does not scan encrypted files. The reason for that being the indexer needs to store little bits of your file for the search. For example, if you have a file that lists every employee in your organization by name, well, you might search for somebody's name and that file would pop up. If that's confidential information, you wouldn't want an attacker to go through the search index and see all those contents because they'd be able to extract every name from the file. Searching and indexing encrypted files can reveal the contents, and for that reason, indexing of encrypted files is disabled by default. But if you want to search those encrypted files, well, you're going to have to turn that option on. Finally, the third challenge that we face is that your log files have a non-standard file extension. They have a .mylog extension. And Windows Search only knows how to index specific types of files. So these log files are standard text files, and it knows how to index text files, but it doesn't think they're text files because they don't have, say, a .txt extension. So we're going to tell it to go ahead and index mylog files and treat them as regular text files. First, we need to open up the indexer tool. So I will search for indexing options under the settings. There they are. So I'll run indexing options. And you can see here that it lists all the locations that are currently being indexed by search. So we need to add a new folder to this. So I'll click the modify button and then browse to the folder My Files. There we go. And click OK. Great. All right. It is now indexing My Files, but that's not the only thing we need to do. Let's take a look at those files in the My Files folder here. So we can see because they're green, that means they're encrypted. And like I was saying, they have an unusual file extension, which means they won't be indexed by default. So let's click this advanced button here so we can go in and change some indexing options. Well, this one is easy. Index encrypted files. That's a requirement for us. So we'll just select this. And you can see this just warns you everything I was telling you about. The search can reveal confidential data within the encrypted file, and as a result, it wants you to run BitLocker, which will basically encrypt the search contents as well. So BitLocker adds a second layer of encryption, which can help protect that data. I'll just click continue so that we enable that. And this is good for troubleshooting. You see this rebuild button here. If things go wrong, if search isn't working right, the first step is always to rebuild the index. So that's where you would do it from. But to meet our next requirement to index that unusual file type, I'll select the File Types tab up here, and we'll add a new extension to the list. And let me just check the name of that extension, mylog. So we'll add the mylog extension here. And you can see by default, it's indexed using the file properties filter. You can see it says index properties only. So it would index the file name. So you could easily find the files by name, but it wouldn't be indexing the file contents. If you want to index the file contents, you got to select Index Properties and File Contents. And you can see that by default, it sets it to the plain text filter. Now there are other filters. For example, it can index Word documents that aren't regular text files because Windows has what's called a search filter. And the filter basically translates the proprietary document format into standard text. Now, if you're a developer, you can create a custom filter. If you're a sysadmin like we are, you're pretty much stuck using the plain text filter. However, most apps that you install, including Microsoft Office, will install custom filters, so documents created with those apps can be indexed. So we've enabled searching for the mylog file type and configured it to use the plain text filter, and we indexed encrypted files. Now, I'm going to tell it to rebuild the index. This happens automatically. Because I've added a new file type, search needs to go back over the whole disk and see if there are any new mylog files. So it basically just starts rebuilding it from scratch. there's no reason for it to start over, but that seems to be the way they've implemented it. Fortunately, it doesn't happen all that often that you need to modify the configuration. So now the search indexer is going to work. And as you can see, well, it says indexing is complete already. I guess it didn't take long. There aren't too many files on this computer at all. So mission accomplished. Oh, I was wrong. It just started up. So now it's going to spend some time indexing all the files on the computer. But when it's done, I'll be able to search and return the contents of those encrypted log files. This is Tony Northrup for TrainSignal, and I hope you found the lesson both educational and enjoyable. And I'll see you next time.